So, all right. So what we're going to look at today is still Unit 10. We're doing Lesson 4. So solving systems by substitution is what we are working on. Now, this is an algebraic method versus a solving equations method is what I mean by that, versus a graphing method. So we've looked at how to solve systems by graphing and where they cross. So to get into this lesson, let me just, I want to share something back over here with you real quick. So what we, whoops, wrong one. Let's try that again. So what I want to look at here is, if I can get this out of the way. One sec, hold on. Waiting room, let me admit a few more people here. All right, there we go. Let me get this to the right screen so I'm sharing the right screen with you. All right, so what I want to look at here is, this is called Desmos. It's a graphing calculator. And so if we look at this first equation over here, I've got y equals 3x minus 5. That's slope-intercept form. And as we see, if I change my scale a little bit so that we can see single digits on here. Oops. We'll just leave it on that, actually. So right here is between -4 and -6. That's the -5 intercept from this equation. And a slope of 3, meaning we're going to go up 1, 2, 3, and over 1. So that's a slope of 3. Now if I put this equation on, the y equals -2x plus 5. Turn it back on. We have the y-intercept up here at +5, and then a -2 slope. So we would go down 2, right 1, all right? And so as we look at these two equations, right, if I click on the line, it'll give me what point I am at. And you'll see these decimal values as we continue down, right? As we get to a place here, for example, we're right at 3, 4. So that point of 3, 4 and every other decimal value point that I see along here would actually make every XY coordinate point here would make this equation true. That's what the line is the visual example of all of the possible solutions to y equals 3x minus 5. All the XY combinations that actually make this equation true. The blue one does the same thing. If I click on it, I can scroll along and look for whatever points. Right up here is the 0, 5. Down here, I've got, get to this one. Somewhere in here is a whole number value. So 3, -1, that point, right, also makes this true. So all of these points along here would make that blue equation true. Every x value that I could plug in would give me that y value that's there on that point. So the reason I'm showing this to you is to show you that from the graphing, we have all of these points that are on the blue line, all of these points that are on the red line, but only this point right here where they cross at 2, 1 is the point where they are the same. And so the point where this thing is true, both the x value and the y value are identical, okay? This is the only place where that happens for both equations. Where the y value is 1 for both of these, it's the same. So in this, where it's true, right, this y value would be 1 and this y value would be 1. So even though I don't necessarily, when I look at a set of equations, like if I didn't have these graphed, right, if I didn't have them graphed, I could know that when I'm looking for the solution, both y values are going to be the same where the solution happens. Okay, where they cross, the y values would be the same. All right, so if y is equal to y here, then this could be equal to this. All right, the 3x minus 5 could also equal the negative 2x plus 5. All right, that's why this situation that we're going to look at today of substitution works, because where those lines cross, the y values are the same. And so if this y equals 3x minus 5 and this y equals, if both of these y's are equal to each other, then these two x expressions are also equal to each other where these lines cross, okay? So that's what we're going to be looking at. So let's go back over here to our notes and go through the process, okay? So substitution method allows you to replace or substitute. Okay, that's why it's called substitution. All right, so we're just going to say replace one variable, either x or y, and we're going to be replacing y, okay, each time for this today, with an equivalent expression containing the other variable, right? And that'll make more sense once we get into the process here of what we're doing. So if I look at this example here, right, I've got y equals negative 4x plus 8, and I've got y equals x plus 7. So that system of equations, we want to know where those things cross. And if I were to graph those things, we will find that they cross somewhere, but they don't cross at an intersection we can easily recognize, not without a graphing program anyway. So with this problem, what I want to do is, in this process of substitution, I'm always going to substitute this y value and this y value out. So if this y is equal to negative 4x plus 8, and it's also equal to this y where they cross, right, then I can basically replace this y over here with this expression, because if this y equals this y and this y equals this, then this is going to equal this, okay? So that's what we're going to look at, and that's what happens here. So that's why the first step is always to just see what we have here. We're going to replace this negative 4x plus 8 in place of that y. All right, and so that's where this first step is, right? Set the two x expressions equal to one another. So negative 4x plus 8 is going to equal x plus 7. So that's step one for this process, okay? Step two then, and this is where we get back into sort of our solving equations with variables on both sides, because that's what we have here is our equation now only has x's. We don't have two variables, we only have one. So we can now solve this equation to figure out what x is equal to, okay? And that's going to tell us our x value at the point where they cross. So this will give us a solution. So first thing I want to do in this is just move all of our x terms. So whatever's on the right side of this, we want to move them all over here to the left, okay? So if this was a negative x term, I would add to do that. Since this is a positive x term, I'm going to subtract to do that. So I'm going to subtract x to get rid of this x, and I'm going to subtract x from this side as well. All right, remember, I'm only going to be subtracting from like terms. So negative 4x minus x is going to give me negative 5x. All right, this plus 8 is still here. And then what's left on this side is just that positive 7, okay? So we will want to, one second, I got someone in the waiting room I need to send a message to. All right, so that's step one. Step two then is to subtract the two x, or the x from each side. And so we're at this simplified equation right now. So the next part of this then is I'm going to take that equation and then I'm going to move all of my constant terms to the right side. So whatever's on this left side, this plus 8, needs to be removed and moved over here. All right, so I remember when we move something across the equal sign, it just becomes its opposite technically. So when I'm taking this plus 8, I'm really subtracting 8 from both sides. So 7 minus 8 becomes -1. So I get this equation of -5x equals -1. Now that seems like a odd set of numbers for this equation, because if I divide, it's not going to go evenly. And that's okay. And the point of why we're doing this example is to show you that we can get to a solution even if the solution is not an integer or even number value. Okay, so when I do this next step, which is to, let me just come down here and zoom in a little bit on it, just focus for you. Sorry about that. All right. So as we do this next step, the next step is to divide both sides by that x coefficient. So in other words, this -5. So I'm going to divide this side by -5, right? And divide this side by -5. So -5x divided by -5 is just 1x, or just x. And -1 divided by -5 is just that fraction, but we don't want a negative over a negative, so we just write it as +1/5, okay? Could it be a decimal of 0.2? Sure, I could write that if I wanted. If we're doing this on an IXL section and they ask you to write it as a simplest form fraction though, make sure to do that in fraction form and not decimal form, okay? So that is step 4. Now there is one more step, because what we have right now is the x value for our coordinate, okay? So we know where these lines cross. They will cross somewhere along x equals 1/5, okay? The way that I get my y value is now I go back to either of these original equations. Doesn't matter which one. You could choose this one, or you could choose this one. You don't have to do both. They will give you the same answer either way. So I'm going to choose this one normally because of the fact that this doesn't have a coefficient on this x, and so I don't have to do any multiplication by 1/5. I'm just going to add the 1/5 to the 7, okay? So I would normally choose this second equation here, because as you see, it only has one step, which is to, once we substitute, is just to add it. And that just becomes a mixed number, 7 and 1/5. So that's a much easier problem to simplify and do than if I plugged it into this one. But if I chose this one, I would still do -4 times 1/5. That would give me -4/5. Then if I add that to 8, it's going to reduce 8 by an amount of 4/5, giving me, again, 7 and 1/5. So either equation will give me that same y value. It's just one is usually going to be a little easier than the other. So depending on which one you choose, you should get the same answer. Sometimes you just get less steps. So that's what I said here. So either one of these things should give you the same result. So just try to find the one that is easier to evaluate. All right. And so this then is our final answer down here. So this 1/5 was our x value, right, that we found from substitution. And then we substitute back in to find our y value in either equation, okay? So a fractional value that if we tried to graph it, we wouldn't necessarily be able to say, oh, that's definitely 1/5, or that's like we would know that it's somewhere between 0 and 1, but we wouldn't know the exact value, right? It could be 1/4 where it crosses, because we don't, without a graphing program to tell us specifics, just manually graphing it like we were doing would have been a more difficult process, okay? So the solution here is a fraction. It doesn't mean you're always going to get fractions when using substitution though, okay? But substitution is a better method when you get fraction solutions versus trying to graph it, okay? Graphing works fine when you're trying to solve whole number problems or integer problems, but it doesn't work as well when you wind up with a place where you can't see exactly where they cross, okay? So any questions on that process, okay? It's pretty much four steps to get to the x value and then one more to get that y value, okay? So let's take a look at this practice problem up here, right? And by following along with your steps, I'm going to call on some people and ask you to tell me what step 1 would be. And then let's see. All right, so everybody taking a look at your notes. Step 1 is to do what? Let's see here. What is step 1 here? So let's go to, let's just go over here to John real quick. Good morning, John.
Good morning.
John, you there? I don't even have my volume on. It's helpful. John, you there?
Hello?
Oh, got you. Sorry, my computer was muted. So I was wondering why I couldn't hear you, but there you are. So, what would be our first step here? Step 1 says to do what?
Well, you'd substitute.
Okay, so
substitute y.
So I'm gonna basically just set the two x things equal to one another, okay?
Yes.
Step 1 is to take those two x expressions and set them equal to each other. So this 2x plus 5 is gonna equal 5x minus 4. All right, so that's step 1. Thank you, John. All right, so step 2. Let's come over here to Nate. Nate, what does step 2 say to do?
Hello. Step 2 says to remove any x terms off the right side by adding or subtracting that term from both sides.
Okay. So which term am I talking about on this one then? On the right side, I'm going to take away this 5x.
5x, and you're going to subtract it on both x's, 2x and 5x.
Okay. And what would that simplify to when I do that?
Well, you cancel out the 5 minus 5x, and then you get negative 3x from the other side.
Okay, so I got negative 3x. That plus 5 is still there. And what's left over here?
Negative 4.
Negative 4. Thank you. Good job, Nate. All right, so let's take a look then at step 3. And let's go over here to, let's see, I want to check in on someone who's been here the whole time. So let's go over here to Cade. Cade, what does step 3 say to do? Cade, you there? I hear some sounds. Cade, are you there? Maybe. All right, we'll come back to Cade. All right, let's come over here to Jesse. Good morning, Jesse. Jesse, are you there? Is my mic still working? Hello, hello. All right, we'll come back to Jesse as well. Andrew? Andrew, are you there?
Hi. Yeah, I'm
Hi,
here.
good morning. All right. So, I'm starting to wonder if I was having technical difficulties. All right, so what does step 3 say to do for this?
So for step 3, you're going to subtract from the plus 5
Okay.
on 5 and negative 4.
Okay.
And then it cancels out the 5, and then the negative 4 equals negative 9 after.
Okay, so this is negative 9. What's left over here?
Negative 3x.
All right, excellent. Negative 3x. Thank you, Andrew. So let's come over here to, let's say, Trevor. Morning, Trevor.
Hey.
So step 4, what would step 4 say to do, and what would we do for this particular problem on that step?
We would divide negative 3x.
Okay, so we're going to divide by negative 3, right?
Or negative 3, yeah.
And divide by negative 3. So what does x equal for that after we've done that?
3.
Right, negative 9 divided by negative 3 is positive 3. So that's going to be our x portion of this solution. So we'll come over here and put that there. All right, thank you, Trevor.
Mhm.
All right, let's come back and see if Cade is rejoined us here. Cade, are you there? Cade? There are lots of noise in the background. All right, we'll come back. Let's see. Let's try down here. We still have. Imagine.
Yes.
So now that we have found the x term, what do we need to do to get the y term? What's that last step on the notes say to do?
To plug in the x value back into either one of the original equations to find the y.
Excellent. So which one of those do you think would be the easier one? And it doesn't necessarily, I mean, you can choose either one, but which one do you think would be the easier one?
Out of which numbers again?
So up here, right, we're going to take this 3 and plug it back in into either this equation, the y equals 2x plus 5, or into the y equals 5x minus 4. Which one of those two equations do you think would be the easier one to plug into?
I say the 2x plus 5.
Okay, I would agree, partly because this number is smaller, right? We can multiply by 2 and keep the numbers somewhat small. This one also has addition. I think most people find addition easier than subtraction. So
Yeah.
So if I go back into that problem, I'm going to just come over here and put y equals, so I'm going to take this, replace the x with a 3. So I'm going to do 2 times 3, I'm going to scoot this a little bit, plus the 5. So that's what I'm replacing is into that equation. And what would we get from this result? What's 2 times 3 plus 5?
6.
Okay.
11.
All right, so answer is 311. All right, and I won't tell you that I designed this problem so that it has my birthday as the solution, but I might have. So anyway.
Okay.
All right, thanks, Imagine. All right, so hopefully everybody is able to follow those just steps, and if you have difficulty, let me know. We will get to those questions. So the thing I want to do here, and yes, Nate, it was my birthday in March, so right before spring break. I think it was the Wednesday before spring break. So let's go to our, let me get to the worksheet again so we can take a look at a few of these problems real quick. So let's see here, screen share that, come on. All right, so I want to point out a couple of things that might look a little different with these on it. Actually, quite a few of these, okay? Notice in this problem, number 1, right? We've got a slope-intercept form, and then we've got just a regular y equals -3, okay? These problems are actually a little bit more simple than the ones we just did because we already know one of our solutions, okay? It tells us y equals -3, so that's part of our solution. That's the y value. So really all we would need to do with a problem like this is instead of using full substitution in the 5 steps, when you have something like this, all right, I'll just do this problem on our screen over here. If I can find my tablet. There we go. All right, let me get to real quick. It looks like I had a hand go up in here. Yeah, what's up, Trevor? Trevor? Do you have a
How did you get 11?
how did I get 11?
Yeah.
So on that, right, Imagine said that we thought using that y equals 2x plus 5, that first equation we had was the
Mhm.
easier equation to plug back into. And that's what we did. We replaced
Okay.
with 3. So we had 2 times 3
Mm-hmm.
plus 5 in that first,
Oh,
and that's what y equaled 11 at that point.
okay. Thank you.
Yep. All right, so let's just take a quick look at number 1 here. So let me get, so it's y equals 7x minus 10. And just write that on our whiteboard here. And we got y equals -3. So those two things. So let me switch back to our whiteboard. All right, so this is number 1 on that sheet. So we'll do this one together just so you can kind of get a sense of what I'm talking about, how these types of problems will be actually a little easier than what we just did, because we've already got one part of our solution. All right, so this y equals negative, so this is number 1 on our worksheet. So this y equals -3x, right? So we know in our solution down here, our xy solution somewhere, we know y is going to equal -3. It's already told us that, okay? So what we have to figure out is x. So really, we're just going to, again, substitute or replace y with this value. So I'm going to take this -3 and put it in place of this y over here, because if y is equal to y, that means that this y equals -3. So I'm going to replace that y with -3 and then figure out what x is from this equation. All right, now this doesn't have variables on both sides, so we're basically going to skip down to getting the variables by itself. Okay, so in the case of this x is already by itself over here. So I would add 10 to move this constant term to the other side. So that's going to give me 7 over here equal to 7x on this side, right? And then this is where we're at step 4 on this, where I'm going to divide by the x coefficient. All right, so I'm going to divide by 7. And so x is equal to 1 in that situation. So that's what is going to be my x value when y is -3. Okay, so there are a few problems on that worksheet that look kind of like this. All right, so these are a little easier than 2 slope-intercept equations because we don't have to move variables to both sides. All right, so it has 1 less step, and actually 2 less steps because we don't have to figure out what y is afterwards. Okay, we just have to figure out what x is. And so this is really just a shorter process overall when we have something like that. All right. So let me just check in with Miss Carey before we split into groups. Good morning, Miss Carey.
Morning.
All right, so I think we're about ready to split into groups. Do you think there's anything else we need to touch on? Any questions you have about the worksheet before we split to groups?
I think we're ready.
All right, let's go ahead and do that. So guys, this worksheet is the 8 problems. We just did number 1 together, so really you only have 7 more problems to do. So we have about 25 minutes. Hopefully we should get most of that done in this time. If you're not able to get it done and want to come to office hours for us, please do that. So let me split, see, 1, 2, 3, 4. It's like I've got 4, 5 for you today, Miss Carey.
Okay.
I'll take the rest here. So All right. All right, guys, so most of these, as you see, as you look at that worksheet, look a lot like that last problem we just did, like number 1. There's about half of them have just a y equals for them. So this shouldn't take too long. All right, but if you've got any questions on this, hold on one second. Derek, let me move you over to Miss Carey's room. All right, there we go. All right, so if you run into any problems, any questions, just let me know. I'm going to go ahead and mute myself, but if you've got a question, be happy to answer it. Obviously, we can't really share screen today other than mine because there's nothing really for you to show me without being on IXL, but if you got questions, let me know. Number 3, okay.
Yeah, I'm not really getting it.
All right, so let's take a look at that one together here. All right, so number 3 is technically a slope-intercept form equation, right? You've got the y equals 6x, technically plus 0, and then y equals 5x plus 7. So this is going to go back directly to the steps from the notes. So step 1 is you're going to take those x terms, x expressions, I should say, and set them equal to each other. So you're going to have 6x equals 5x plus 7 as your first step.
Mm-hmm.
Okay. And then step 2, you're going to do what?
Oh, I'm sorry, what?
And then your second step would be to do what?
Second step, wouldn't you subtract the x values on both sides, 5 and 6? Like
Yes,
you
so-
subtract 5 and 5 and 6 and 5.
Yeah, so you'd subtract the 5x from both sides to get that off the right side.
All right.
So at that point, what does your equation say?
1x.
Equals,
All right, 1x equals plus 7. Yeah, positive
Yeah.
7.
so at that point, you're pretty much solved for x. You don't have to do anything else because there's no other constant on the left side at this point. So step 3, which would be to move things, and step 4, which would be to divide things, don't really exist because there's nothing to move and nothing to divide, right? Because it already says what x is equal to. So at that point, you have your x value, and then you can plug that back in one of those 2 equations to figure out what your value is equal to.
So Peters, I need help. Mr. Peters,
Yes, what's up,
I need
Trent?
help.
On?
Number 2.
Okay. So did you follow what we did on that last example when we did number 1?
Yeah.
So same idea there. You're going to replace in the y equals negative 2x minus 12.
Mm-hmm.
That equation, you're going to replace the y with negative 8. So
So
it
the
should.
x, wait, so the
it would
x would
say,
be -8?
so it would say negative 8 equals negative 2x minus 12. That would be your first step, is to replace the y in the other equation with
Okay. So x would be -8?
no, y becomes negative 8.
Oh,
So your first step should have an equation that says negative 8 equals negative 2x minus 12.
okay.
You're just going to replace this y right here with that number.
All right.
Because you're going to replace the y with the value for y.
Okay.
And then you would solve that for x.
So it would be -8 equals -2x minus 12?
Yep.
All right.
Then you would add 12 to both sides to get the x by itself, and then divide by negative 2 to figure out what x is. So Nate, did you get an answer on 3?
So it's not really. I mean, didn't you say like the 1 was the x value?
So what did you get for x? It says x equals what?
I got something like x equals 1.
No. So you got your initial equation was 6x equals 5x plus 7, right?
Yeah.
Then you subtracted 5x, and what did you get?
1x.
Or just x, right?
Yeah.
1 is the same as x.
Yeah.
What does that equal?
Say that again.
What does it equal? What's on the right side of the equation still?
Plus 0 for 6x. Oh, no, I'm sorry. Oh, plus 7. Yeah, it's
Yeah.
just positive 7.
Yeah, so you get 1x equals positive 7, or in other words, x equals 7,
All right.
right? So that's your x value. To find your y value, just go back to either equation and replace x with 7 to figure out what y is.
Oh, I see now. Okay. Thank you.
Yep.